Hi all, I'm just going to go through a product teardown with you here. So I've been through my shed to see what is available to me, and I would recommend that you try and find something which is feasible to tear down. I found this old heater from Lidl, so Silvercrest heater, and just looking at it, the first thing I notice is that underneath it's got some very standard screws, so I know that at least I can take those out. It's got a molded on plug which unfortunately cannot be disassembled. You can take out the fuse, but nothing more can be done with it. And when I look at the side here, I can see the information on the power rating. So it's got a power rating of 2,300 watts. That's quite a lot of power, but it's also saying that it's a convector heater. So when I look on the inside here, I can see the convectors. There is some sort of a fan which will blow through and bring this heat through it. So I'm going to start to try and tear this down now. So I've assembled some tools here which I can use for my teardown. Obviously it will depend on what you have at home as to what you're able to use, and perhaps it might be useful to make sure that you are choosing a product which you do have the ability to disassemble. So I've got some hammers here. Chisels can be very handy for something which has a tight push fit on it. But if you don't have a chisel, a butter knife can be useful. It would be good to have screwdrivers and the various fixings, which, you know, many products have non-user serviceable parts, so they tend to have star fixings in them. It would be good if you can get your hands on various tools which are able to get past these. A pair of gloves are always good to make sure you don't hurt yourself, and if you have a drill, can often be useful as well. So try and assemble what you can from what you've got at home. So as I start to remove the screws here, I see that some of them have different heads than others. So you can see here there's some sort of a 3-piece head as opposed to the normal Phillips head. As I'm removing them, I'm just gathering them into bunches so that I can put the various parts together. Okay, so I have managed to take the front plate off, which is constructed of powder coated steel. You can see where it's bent into shape, and it's also got this injection molded component which contains the controller, and that was connected over here onto the fan and the heater panel. Screws. So we got an injection molded piece here. It's polypropylene PP marked on the inside. And we've got our PCB panel. So we can also see that we've got our LED, or our LCD, LCD, liquid crystal display screen. And here are the springs which control the buttons on the outside, and the connection to the fan and heater. So at this point I'm not sure how much further I can go on this panel. It doesn't look like I can easily disassemble these pieces. For your life cycle analysis, we can put this in as one component, so we don't need all the individual bits and pieces, because obviously there's a huge amount of complexity involved when we have printed circuit boards, which are PCBs, or liquid crystal displays. It would be impossible to put all the individual components of these into a life cycle analysis. I've still got these two very difficult see these fixings have created a lot of difficulty for me, and you'd wonder whether under the new EU right to repair rules, whether this will still be permissible in the future. So we can see both front and back panels have these earth connections to ensure that a user doesn't get electrocuted if there is a short. That will ensure that the heater, the electricity will go to ground immediately. So now I am left with the main working parts of the heater. So here we've got our fan with a motor in it, and a turbine, which is then connected also to our heating panel, which is where most of the electricity is used. So each one of these is a nitinol wire, which will heat up when electricity is passed through it. And we've got a mica piece at the back, which is able to withstand really high temperatures, and holds it all together. So now I'm just going to try and remove lots of these. We've got some cable ties and pieces in here, so that hopefully I can remove the plug and flex to get a little bit deeper into it. This is a zinc coated steel plate, which was probably structural, keeping the two parts apart, and has the strength to do that, and also holds the fan in place. See the screws on the PCB, all of these red little washers on them, and presumably that's to prevent conduction from the electrical board. So now I'm left with the motor connected to a fan that pulls in air through the heater and runs it over the nitinol to take the heat around the room. We've also got a controller board here, which has various different items on it, capacitors. I think this is a little buzzer here with the opening on top of it, which is probably a little piezo to tell me if there's something wrong. We've got, you can see the resistors, which are these color coded pieces, and we've also got a fuse here. So again, we won't be able to do a deep analysis of this, but we can put it in as one component in our life cycle analysis. Okay, so I am going to, now that I have it all disassembled, I'm going to look at the way the energy flows through it. So we're coming here from our plug, which is molded on and can't be disassembled, unfortunately. So that's the first thing I see wrong with it. Through copper wires, and cross-linked polyethylene is what they usually use for coating those wires. We've got our polypropylene housing, we've got a switch with an LED in it. That comes through to, there's a thermostat on this piece here, which would be taking the temperature from the room and deciding when it switches on and off the heater. You can see clearly here we've got our wattage on here, 2300 watts, which is also on our heater element here. So it also clearly says 2300 watts. Electricity is then coming through to this controller board here, which is connected to our controller, which the user can use on here. So electricity flows through here, and it decides when to switch on the motor, which runs the fan, and when to switch on the heating element. So these are the two pieces that we are controlling, and we can set our temperature on here. This temperature would be coming back into the room and checking with this thermostat. We have our PCB controls. Most of the parts are polypropylene. Most of the plastic parts, apart from the housing here, which is ABS. Probably because ABS is a bit more aesthetically pleasing when it comes to buttons and switches. It doesn't have the softness that polypropylene has. And we've got some zinc coated steel here, and we've got powder coated steel here on the two housings. Our earth connection is the only other piece. Okay. So along with your inputs and outputs for your life cycle analysis, you will also need the materials, manufacturing process, and weights of each of your components. Obviously for bigger components it's a little bit easier. If you have a weighing scales at home, it would be really good. Obviously for a lot of these components they are really small, so it can be difficult. I have got a really accurate one here, and I can give you estimates for your small components like screws, for instance. That's 0.6 of a gram, for instance. So if you can line up all your components, you will need to know material, manufacturing process, and the weight of each single item to conduct a proper life cycle analysis.